Hey guys, we're going to go over trig derivatives now. If you are in calculus, this is a continuation of 2.3. If you are in pre-cal and we're starting to learn calculus, this is from 2.5, okay? So the trig derivatives, this should feel like an easy lesson. We are going to go over the 6 main trig functions and what their derivatives are. I have a little set of what I use as tricks to remember the details in the derivatives. And then we'll just do a few examples and incorporate product and quotient rules to practice a little bit. But this lesson should feel pretty simple. It's just really memorizing, okay? So on this left side, I have the original functions. And on the right side with the primes, I have the derivatives of those functions, okay? Oh, sorry. So let's take a look at these tips, and then I'll go one by one. The derivatives of c's are negative. So the derivative of cosine, cosecant, and cotangent are the three that have the negative, okay? C's stick together, and sine and cosine are each other's derivative. So cosine is sine's derivative, and a negative sign is cosine's derivative. After that, C's stick together. So notice that cosecant has cosecant and cotangent. There are no C's here. There are no C's here. And then cotangent has a derivative of negative cosecant squared. Okay, so we see the C's stick together, and then sine and cosine have each other. All right? Tangent and cotangent have squares. So tangent and cotangent have the two other reciprocal functions with the C's sticking together. Tangent is secant squared, and cotangent is negative cosecant squared. And lastly, cosecant and secant have themselves and the function that had them. So, for example, we just said that the derivative of tangent was secant. So when I go to do secant, it has itself and the function that had him or her. Okay, so the derivative of secant is secant tangent. Same thing for cosecant, okay? The function that had a derivative of cosecant was cotangent, and we remember that because C's stick together. So the derivative of cosecant, it's a C, so it's negative, is itself cosecant, and cotangent, the one that had him. All right? So just to go in order, derivative of sine is cosine, derivative of cosine is negative sine, derivative of tangent is secant squared, derivative of cosecant is negative cosecant cotangent, the derivative of secant is secant tangent, and the derivative of cotangent is negative cosecant squared. All right? So make sure you have that list written down. The sooner you memorize it, the easier this becomes. You won't have to keep peeking at that list. But let's check out some examples. Okay? This first one here has an x minus a tangent. Okay? These are separated by subtraction. And the rule when you're separated by subtraction is to solve one at a time. So I can say y prime equals, well, the derivative of x is 1. I bring down the sign. And the derivative of tangent, according to my chart, is secant squared of x. And that question is that simple. Okay? Let's look at this next one. Y equals x times secant x. Well, when two functions are separated by multiplication, I know that I have to do the product rule, which we learned last lesson. Okay? So y prime, if this is my f and this is my g, I have to do first, okay, times derivative of the second. Derivative of second is secant tangent plus derivative of the first times the original of the second. All right, so let's go over that product rule one more time. Just so you have an idea, this was me doing f times g prime plus f prime times g, okay? So we wrote the first, original first, derivative of second, which we got from our chart, derivative of secant is secant tangent, plus derivative of the first, derivative of x is 1, and then rewrite the second. Now all you have to do is clean if possible. So here I can't really clean anything. I'm just going to write it all together. X times secant tangent plus 1 times secant is just secant. Okay. If you plan on taking AP, or if you're currently sitting in my AP class, don't be surprised if sometimes they'll try and throw you off. The fact that there's two terms here. There's one here and one here. The fact that both terms have a secant, they could do this to you. They could take a secant out, factor it out, and then leave what's left over. Remember, if I divide out a secant from here, I'm left with a 1. These are just options that you could find like in a multiple choice. You do not need to clean it that far though, okay? All right, let's check out these next two questions. So this one over here says sine divided by 1 minus cosine. Okay, because I have division, this is a quotient rule. Okay, remember low d high minus high d low over low squared. So y prime equals low then d high, derivative of the high, so derivative of sine is cosine, minus high, which is sine, and then d low, derivative of low. So derivative of 1 is 0, that's going to disappear, minus derivative of cosine is a negative sine. Whoops, I'm running into the other question there. Okay, all over low squared. Remember, you do not have to clean the bottom. Okay, so I'm done with the calculus. Now I need to clean. I'm going to distribute this cosine. Okay, now these two negatives are going to make a positive. So I'm going to have this 0 is going to disappear. I'm going to have a positive sine times a negative sine, okay? So let's start over here. Cosine times 1 is cosine, minus cosine times cosine is cosine squared, all right? And now I'm over here. This negative sine times this positive sine gives me a negative sine squared of x, all over 1 minus cosine of x squared. Now, technically, you are done here. So if you were in AP and you were doing a free response question, you could stop here. But let me show you what would typically happen in a multiple choice, okay? Sine squareds and cosine squareds together should be a red flag for you, okay? Because cosine squared plus sine squared is a Pythagorean identity that equals 1. It's a very common identity that they do clean up in AP tests, okay? So if I wanted a plus sign here, I would have to factor that negative out. So I could say cosine of x minus, and then I could say cosine squared plus sine squared over 1 minus cosine of x squared. So we know that this right here is a Pythagorean identity. Okay? And so I can rewrite this as cosine of x minus this equals 1 over 1 minus cosine of x squared. All right, so this is one possible answer. I just want to keep exposing you as to different ways that they could clean this, okay? Not that you necessarily have to clean it this far. Anytime you see that you have the same terms with opposite signs, or perfectly like reverse, so there's a negative one here and a positive one, and a positive cosine and a negative cosine, I can switch the order and factor out a negative, and then they'd be identical. For example, if I say -1 plus cosine of x, I just switched the order. I could get these two to have the same exact sign if I factor out that negative. Okay, so if you're getting a little confused as to how we got here, imagine if I'd multiply this -1 in. I'd have a -1, and then multiply it here, I'd have a positive cosine. Now, the reason why this is beneficial is because I have a 1 minus cosine on the top, and I have 2 of them on the bottom, and you could clean this up all the way to -1 over 1 minus cosine. Okay? So again, you do not have to clean this far. I just wanted to expose you as to what would happen. For example, you could stop here like on a free response we said, but multiple choices would at least clean to here, but they could do this to you if you're in AP. So just so you have that exposure, okay? Let's check out this next one. I hope I have enough room here. All right, so let's draw a little line. Let's see if I can make it fit. All right, if my function is x squared times cotangent, I know that that multiplication means that I have a product rule. Okay, so y prime is rewrite the first times derivative of the second, and I'm just going back to my chart for that, plus derivative of the first times rewrite the second. Okay, so one more time, original of the first, derivative of the second, plus derivative of the first times original of the second. Now I have nothing really that I can clean except maybe just putting this negative in the front. The reason why I like putting negatives in the front of the term is so it doesn't look like it's x squared minus cosecant squared. So we could say a negative x squared cosecant squared of x plus 2x cotangent of x. That is a final answer. You could see an x factored out, but not necessary. If you did product in a different order, which again is allowed, like let's say here I would have done the derivative of the first term first, wrote the original, and then vice versa, you would just see this in the complete opposite order, okay? Which is still 100% correct as long as this term has a negative and this term has the positive. So for example, it could have said 2x cotangent minus x squared cosecant squared. If you see that in the back of the book while you're checking, that's totally okay. All right, let's check out one more question. All right, for this last question, we're going to step it up a notch and we're going to implement different strategies that we've learned. Nothing new though. It says find f double prime, which means the second derivative, at pi over 4 if f of x is cosecant of x. So step one that we're going to have to do is we're going to have to work on finding the second derivative, okay? So with f, let's switch colors. So if f of x is cosecant, I know that based off of my rules, f prime of x is negative cosecant cotangent. Okay? So I just made my way to my first derivative. Now before plugging in pi over 4, I do have to get to that second derivative because they don't care about f single prime of pi over 4. They just care about f double prime of pi over 4. Now for my next step, to do the derivative of negative cosecant of x times cotangent, okay, this is multiplication, I'm going to have to do product. Okay? So this is going to be my f, and this is going to be my g. Okay? So remember, for f double prime of x. For my next derivative, I'm going to have to do product rule, which I'll write this one out just to make sure we don't lose track. Original first times derivative of second plus derivative of first times original of second. So original of first, and I love putting everything in parentheses. I think it really helps everything to be clean and clear. Times derivative of the second. Well, derivative of cotangent is a negative cosecant squared of x plus derivative of the first. Okay? Be careful with that negative. Derivative of cosecant is a negative cosecant cotangent, but I have a negative. So I'm going to put that negative, that one right there, I'm going to just bring it down like if it was a -1. And then I'm going to say times the derivative of cosecant is a negative cosecant cotangent. And then times g, which is the original, and it's just cotangent of x. Okay? So if you were following along with these four, they should match up with your parentheses, okay? Now, you have the option of plugging in the pi over 4 here, okay? Or you could clean it a little bit and then plug in your pi over 4. Both will get you the correct answer. I think if we clean it first, for example, this can become a positive cosecant cubed. It's going to make my work a lot easier, okay? Especially since we have these similar ones. So for starters, this negative and negative is going to become a positive. And then I'm going to I have one cosecant here and two of them there. So with 2 and 1, so we have a cubed, okay? And then here, these two negatives make a positive, okay? And now I have one cosecant, and I have two cotangents. So I'm going to say plus a single cosecant times, there's two cotangents, so I'm going to write cotangent squared, okay? So now that I have finished finding my second derivative, I need to plug in that pi over 4. So now that I'm going to do the plugging in of pi over 4, that's when I'm going to write the notation. Now, every time you have a trig function with an exponent, I'm going to encourage you to write the exponent on the outside with parentheses. So for example, I can say cosecant of pi over 4 cubed. Meaning I can find cosecant of pi over 4 on my unit circle, and then that value, I'm going to cube it. Okay? And we'll see that on the next step. So this one is just cosecant of pi over 4 to the first power. And this one's going to be cotangent of pi over 4 to the second power. So for this next part, we're going to have to go to our unit circle. Cosecant of pi over 4, it is the, well, at pi over 4, we have radical 2 over 2, so we have to flip it because it's cosecant. So we're going to have 2 over radical 2, and then all of this will get cubed, okay? Plus, it's the same value, just to the first power. And then times cotangent of pi over 4. At pi over 4, both ordered pairs are radical 2 over 2. Cotangent is to divide cosine by sine. Anything divided by itself is 1. Okay? So now, remember when we have an exponent, we cube both the numerator and the denominator. 2 cubed is 8. Over, and if I cube this, it's like saying I have in the square root, now I have 3 of these 2's. Okay, plus 2 over square root of 2, because anything times 1 is just going to be itself, all right? Now, on this next part, remember that when you have a square root, as long as you can find a pair, 2 of them can come out, okay? because that'd be like saying 2 times 2 is 4, square root of 4 is 2. So I can say 8 over, whoops, sorry, root of 4. So we say 2 square root of 2 plus 2 over square root of 2. Okay? Now this 8 and 2 can be reduced. 8 divided by 2. 2 goes into 2 one time. 2 goes into 4. Excuse me, goes into 8 4 times. So what I'm really working with is 4 over radical 2 plus 2 over radical 2, which is really nice because now we have a common denominator. And I could say that my answer is 6 over radical 2. That's it.